indices review. You'll remember that x squared means x times x. The x is the base numeral, or the base. This is the index, or the exponent. The whole thing is a power. When we write it as x times x, that's expanded form. We can have indices with variables or with numbers. So 3 cubed is 3 times 3 times 3 in expanded form. 4 squared, 4 times 4. If we want to evaluate, 4 times 4 is of course 16. So if the question asks us to evaluate, we calculate the actual answer. This is the expression in index form, and 4 times 4 here is an expanded form. We can multiply indices together or multiply by a coefficient. So 4x squared y cubed is 4 times x times x times y times y times y in expanded form. We could, in fact, expand 4 to 2 times 2, but generally we won't. The index laws. The index laws are used when we're performing operations with powers, and they're used as shortcuts. Instead of expanding to find the answer, they're a shortcut. Index law 1, for example, is when we are multiplying two powers with the same base numeral. Here I've got a squared times a cubed. We could solve this just by expanding. This is a squared, I'll underline it, and we're multiplying that by a cubed, underlined. Because we know our basic indices, that's a to the power of 5. So I could have solved that by expanding, but you'll note that there's a shortcut. To get from a squared times a cubed to the answer, I can just add the powers. So if we write this as an algebraic rule, a to the power of m times a to the power of n equals a to the power of m plus n. If we're multiplying indices or powers with the same base number, we can add the pronumerals. That's index law 1. Index law 2 is about dividing. If I've got a to the power of 4 divided by a squared, again if I expanded that out, a times a times a times a divided by a times a, remembering that we can cancel factors from the top and the bottom. That would leave me with 1 times 1 on the bottom here, which is of course 1, which in a fraction can disappear. My answer is a squared. Again, without expanding, we can go straight from our question to our answer, in this case by subtracting the indices. So a to the power of m divided by a to the power of n is a to the power of m minus n. That's our second index law. Third index law is a little different. My example here is I've got a squared, and all of that's the power of 3. If I expand that out, that's a times a, 1 lot of a squared, times a times a, times a times a. That's a squared cubed. And you can see that what we get is a to the power of 6. Again, looking for a shortcut, that means that I've simply multiplied the powers. So when I'm raising a power to a power, I can take a shortcut by simply multiplying indices. So that's index laws 1, 2, and 3, and our indices review.